Day 510 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1089, duplicate zeros. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a fixed length integer array R, duplicate each occurrence of 0, shifting the remaining elements to the right. Note that elements beyond the length of the original array are not written. Do the above modifications to the input array in place and do not return anything. All right, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input R equals an array of integers 1, 0, 2, 3, 0, 4, 5, 0. The output is 1, 0, 0, 2, 3, 0, 0, 4. Explanation says, after calling your function, the input array is modified to 1, 0, 0, 2, 3, 0, 0, 4. Okay, so let's break this down one step further. First thing we want to understand is every zero that we see, we want to add another zero, right? Hence the name duplicate zeros. So we just want to duplicate each zero that we see when we're looping through the array, but we want to keep the array of the same length. So every extra zero that we add, that means one element is going to get pushed out from the end. Because as you can see in this array, we have 1, 2, 3, 4, 5, 6, 7, 8 elements. And in the output, we still have 8 elements, even though we duplicated the zeros. We have 1, 2, 3, 4, 5, 6, 7, 8. So what that means is each time we added a zero, first we added this zero. So when we added this zero, we had to push this zero out of the array. And then when we added this zero, we had to push this 5 out of the array. So in the end, the array just looks like this, so that we were able to duplicate the zeros and keep the length of the array the same. So just in case that didn't make sense, let's take a look at example 2. Example 2 is a little trick question because there are no zeros. So let's take a look at it. So in example 2, we have our input array, or our input R equals an array of integers 1, 2, and 3. Our output is 1, 2, 3. Explanation says, after calling your function, the input array is modified to 1, 2, 3. So since there are no zeros in this array, then there were no zeros to duplicate, meaning there was nothing to modify. So we return the same array. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it. Now, the first thing we are going to want to do, y'all, is we are going to want to declare variables. So to do that, we could come right here. Sorry, y'all. We could come right here. We could declare a variable called I, and we could just set that equal to 0 just to start. Now we are going to loop until the pointer reaches the end of the current array. So this is where our variable I, that's going to be our pointer, and we want to loop until our pointer reaches the end of the current array. So for that, we can just use a while loop. So we can say while I is less than r dot count, boom. Then we can open up the brackets. Now, when a 0 is found at the current index, we need to check the current index to see if a 0 is found. So we can say if r square bracket I equals 0, then we can open up the brackets. And we need to insert an extra 0 right before the current 0, and this is going to shift all of the elements to the right by 1 position. So we're going to say r dot insert, open up the parentheses, we're going to say 0, comma, at, colon, I. So that's going to insert a 0 at index I. Then we need to remove the last element to keep the array length unchanged, because the problem requires that the array stay the same size. So once again, remember I was talking about how these two elements got pushed out. We need to push those out. So we could say for each 0 that's added, we could just come underneath this and say r dot remove last. Boom, just like that. So now we push, every time we insert a 0, we're pushing out the last element of the array. But we also need to skip past the newly inserted 0 and the original 0, which is at the next index, so we don't duplicate it again. So for that, we could say I plus equals 2. Boom. And then just to keep going, we could say else. We come right here. So if we don't have to insert the 0, we could just increment I by saying I plus equals 1. And then when that's all said and done, it's all said and done now. That's all she wrote. So let's go ahead and give it a run. We don't have to return anything because it's an in out function because of this right here. That's why we could just leave it like this without a return. So now let's go ahead and run it now that it's accepted. See what that looks like. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.